How's it going, everybody? In this video I will be teaching you about the 74LS32, which is better known as the OR gate. This chipset has a total of 14 pins, of which its 7th pin is the ground and its 14th pin is meant for the VCC. In it there are 4 OR gates, each of these taking 2 inputs and generating an output. Starting from pin 1 onwards, the first and second pins shall be for inputs 1A and 1B, followed by a third pin reserved for the output 1Y, which contains the resulting value from the Boolean algebra operation A plus B. This pattern continues throughout the chipset, meaning that there is in fact a 2A, 2B, and 2Y, so on and so forth, of course skipping pins 7 and 14. Now we shall return to our Excel spreadsheet to proceed by generating the OR gates truth table. Like we said, we need to establish our inputs, which will be A and B, and our output, which will be Y. We shall also create an extra comments column. And for our base case, we said that the Y, which is the output, would represent the Boolean expression's result of A plus B. The behavior we can expect from the OR gate goes as follows. Using the n equals 2 input along with the 2 to the n formula, we calculate that there are a total of 2 to the second power, which equals 4, possible combinations or scenarios to handle. A high output of 1 results if one or both, that's right, at least one of the inputs which are connected to the gate are high. If neither input is high, a low output or logic 0 will be the result. Now we shall proceed by stating these combinations. The first is when A equals 0, B equals 0, Y will also be 0. Since neither A or B equals 1, Y will be low. The second scenario is when A equals 0, yet B equals 1. The output will be high, because at least one of them was high. Since at least B equaled 1, Y will be high. The third scenario is when A equals 1, B equals 0, Y will be high. Since at least A equals 1, Y shall be high. And last but not least, when both A and B, that's right, when both of them are high, the output will remain high. Since both are equal to 1, the output will be high. Now let me give it some conditional formatting, add some color to it, and the borders. I tend to get all my tables the same aspect or appearance. There we go. We are done with the truth table. It is important to understand that these inputs, A and B, are variables, meaning they can represent any Boolean expression's output value. Now I shall open a Logisim simulation to demonstrate our truth table. This will be a pretty basic example. All we shall need are 2 pins, which we shall point facing south, and its label will be located at the north position. We said that we needed A, which we shall set here, and an pin for B, which is our second input. Now the only thing missing will be an OR gate, which is one of the components inside the 74LS32, but since the chipset that we just mentioned is the quad 2-input OR, we must manipulate the OR gate and change it from its default, which is 5 pins, to just 2. Now for the output, we shall display it using a light emitting diode, which shall be facing west. And now the only thing left will be to connect the pins to the gate using these wires. As you can see, currently both values are low, meaning that when they go through the OR gate, the output shall also be low, and it will remain turned off. That was case 1. Now using our index finger tool, I will change the value of B to be moving on to the second case, and since at least B is high, then the output will be high. As you can see, the LED turned on and it changed color. Now I will turn it off and I will turn on pin A. As you can see, the output is high because at least A was high. And for our last case, when both inputs A and B are high, the output will remain high. As you can see, the LED is bright red, meaning that our truth table was in fact correct. I know this is a pretty basic example, but it is important to understand this base case because when we are working with more complex and elaborate logic circuits, these inputs could be completely different Boolean expressions or logic functions, and you must understand the behavior of each component individually so that when this bigger plane or map is simulated, you can understand what is going on. If you enjoyed this video, please give it a thumbs up and subscribe to my channel for more videos like this. For any comments or questions, you may contact me on the following places: at Twitter at Giovanni0918 or at Google Plus at +Giovanni Orlando I7. Thank you for watching. Have a nice day.